Hi, and thanks for watching another instructional video for CSUI 1300. In this video, we will cover inheritance in C++ and how this relates to building large programs with multiple classes. In object-oriented programs, inheritance is a design methodology where a relationship hierarchy exists between classes. By this relationship hierarchy, we are going to use the words base and special for the relationship dynamic, which can also be referred to as a parent or child relationship dynamic. Special classes inherit the attributes of the base classes. For example, a vehicle class would be a base class, and classes such as truck and car inherit the attributes of the base class, vehicle. For example, here we can see that if vehicle is our base class, we can derive or inherit classes from it such as motorcycle, car, truck, and we can then do that another step further and say that from cars we can get sedans and SUVs. So sedans and SUVs will inherit the properties and attributes of cars as well as vehicles. For instance, another way to think about this is to think about vehicles have the attribute that you can go from point A to point B with a vehicle. And depending on how you want to do that, you can have a derived class from the vehicle class. So for instance, say you wanted to use a motorcycle, well, it would be part of the vehicle overall hierarchy, but it is a subset. So you can think of derived classes similar to subsets of a base class or a general class. Here we can see that we have a relationship hierarchy from the stream classes, which is actually a really good example. So notice that we have iStream and OStream, which relates to doing input streams and output streams. And from that, we can derive three classes from input stream: iStringStream, IFStream, and IOStream. From OStream, we can derive three other classes: OStringStream, OFStream, and IOStream. Notice that IOStream inherits from both iStream and OStream, and FStream, the entire class, inherits from IOStream. So because of this, FStream is able to read and write, and we can do input-output operations in IOStream as well. To create a derived class, we will need to create a class related to the derived class name, add a colon symbol to denote inheritance, and then tack on a modifier for the base class. It is always recommended to add the public modifier in front of your base class so you can always access the attributes or variables or functions related to the base class. If we declare functions in the derived class, they are added here and have a scope in the derived class only. And on top of that, they have the ability to override the functions from the base class, so they have a higher priority. And any private variables, any data members that are added to the derived class are in the scope of the derived class, but not in the scope of the base class. Types of inheritance that might be applicable to your projects include single inheritance, where one class is a parent to another class, a child class, and inherits all of the properties and attributes of that child class. Another such type of inheritance is when we take this a step farther and we have a parent of a parent class that has a child class. So we can see here that if class C is our parent class, then class A would be a base class of C, and B would be the parent class of A. So C would inherit from B, which would inherit from A. B would inherit from A, but would not inherit from C. Multiple inheritances can also occur here. So if we have a parent class C, we can derive it from a class A and a class B. We can also have hierarchical inheritance here, where we can have a single class that has two parent classes. So here, B and C are both the parents of A and share or inherit all of the attributes and functions related to A. Hybrid inheritance is also possible, where we could have a base class that has two parents, and those two parents have a grandparent class or a parent class of their own. So here we can see that D is derived from B and C, and B and C are derived from A. So D would inherit all of the properties and attributes, private variables, related to B, C, and A. B and C would relate all of this information to A, but not to D. So I hope that this is helpful when designing your projects, especially when you're dealing with multiple class types. And keep watching because we're going to do some additional videos to cover implementations of class hierarchies in the future. Thanks for watching, and happy coding!